Welcome Michelle Munson from Eluvio. One of the threads that's run through everything that our previous three speakers have spoken about today is the challenges in moving content around seamlessly while saving bandwidth, while maximizing quality. Eluvio talks about that on a very large scale. And so I'm excited to welcome Michelle so she can share what Eluvio's been up to. Michelle.
Thanks so much, Eric, and thanks for having us. This is our first time to be part of the Streaming Media series, and it's exciting for me, given all the themes that you're talking about with regard to transformation. Just to set the stage, Eluvio is a new company that I started with Sherban Simu about 2.5 years ago. And like many people have said, we've been fortunate that the technology's been dramatically accelerated through this COVID time. Hopefully that'll become clear why. And I wanted to present this today to share it with the audience and let you know the approach we've taken, and then also what we're doing with our customers. The foundation, my opening slide here, whether we feel like it or not, the internet was actually built for web content as we know it right now, not so much for video natively. And a few high points on that. The content distribution network technology that we use was literally introduced to the market in about 2000, 20 years ago, 1999. And with that, also, we have a very well-established adoption of the cloud, which includes microservice chains that are heavily adopted and rely on transcoding and packaging. One of the upshots of that, of course, is that together, those architectures have given us, if you will, some constraints around cost, some assumptions about how things are done, and some constraints around quality. One thing that's very evident from this is that internet distribution control governs everything in monetization right now, and the whole industry's configured in response to that over the last year. And then finally, creativity in content technology, which is truly explosive right now, is very much limited at scale by how the technology works and by the supply chain, which is infinitely complex. So with that, one key underlying theme we see everywhere, and a couple of the other speakers mentioned this too, is that digital distribution is dominated by variants. Variants in terms of devices, platforms, languages, streaming bit rates, and nowadays even formats. And with that, we have a content distribution system that's sort of taken for granted, right? The idea, of course, in pretty much every large-scale internet situation is that video will be prepared, packaged, transcoded, and pushed through some or multiple global CDNs for the purpose of caching. That, of course, works because we're doing it every day, but it comes with some costs. One side of that, of course, is that the internet core, of course, is utilized over and over again for all of those variants and all of the streams. And we actually saw the ramifications of that in March in Europe with what was really a form of congestion collapse that forced overt lowering of bit rates and more contortions to try to change in upstream encoding to cope. Another thing that's absolutely true is it's difficult to achieve very low latency consistently. And if you follow the internet video engineering community, for example, all of the low latency specs that have come out involve certain amounts of complexity, either or downsides with player protocols. And of course, we're doing low latency, but again, at the cost of having to either change origin servers, use new variants in HTTP protocols, or then beyond that to also rely on new player technologies to keep up bit rates. So with that said, it lays the foundation to potentially take a different approach. And that's what I want to talk about today. It is quite radically different, but the goal is to have something that can really address video natively over the internet. And what we focused on here at Eluvio is making a software substrate that runs globally and is really targeted at premium video that self-generates. And by self-generate, I mean that the consumables come directly from the source via the capabilities of the software network. Of course, in this process, there's huge simplification opportunity, and that is that it does eliminate and does not use traditional transcoding services, databases, microservices, or CDNs. And it does that through the innovation in this software stack. I've very much enjoyed working on this over the last couple of years, and we feel like as a result of changes in computing, it's been possible to really bring this to scale. The underpinnings of the stack are a new decentralized data distribution and storage protocol that we created. And that doesn't use file copies. It's effectively bandwidth and storage efficient by design, and allows for what you would think of as no round trip time routing of content parts throughout the network. The output video is in fact transcoded and packaged just in time from this decentralized foundation through a dynamic approach. And then each of the objects happens to have a blockchain identity within the fabric itself. And that allows for versioning and access control rights that are part of the objects. The media is also inherently tagged through machine learning models that are native in the fabric, and that metadata becomes input data into these dynamic objects that are the source for output media. To actually get this real, if you will, we've deployed it onto a network of nodes that we run at internet exchange points. And those nodes work together to allow this kind of dynamic stack throughout the fabric. What happens in this exactly? First and foremost, you can see that it really works right to left rather than left to right as we would think of more traditional video. And that is request to get consumable media, adapted bitrate streams, for example, including the segments in the manifest, downloadable packages, for example, resized images in terms of more static content, or even just metadata. That request drives the fabric to produce the output. Now, that's a very idyllic kind of concept, and to do it at scale repeatedly requires the functioning of this stack over a highly decentralized network, and that stack work without delay or latency. And a few of the things that make that true are that underlying data layer is uniform. Those parts are blobs of data that shard throughout the network, and those blobs consist of the media, the metadata, and the code. At the time of request, those are found without delay, and the code parts load and operate on the media. That also gives, of course, the opportunity to make this fully programmable. So things that we typically have been hard, like building slices in linear channels or doing overlays, for example, is inherent to the structure of this. And then finally, a contract interface is really a software-based access control that's in the object itself. And that's very useful because it puts the rights directly into the content object. It also allows for the fabric to be trustless. And that's quite different than today's clouds. And then, of course, carries on this idea of being able to continuously scale it irrespective of which media is where, and also allowing for different media to coexist in the same shared substrate. And this gives you a little visual of what it looks like. I mean, one of the questions I often get asked is, well, do I have to do something special on the input side? And are there special players required on the output side? And the answer to both of those things is no. Many of you know me from Aspera, and one of the key things that I learned from that experience was the fact that absolutely nothing on the in and the out in the world at scale can change. And what I mean by that is change from what is standard. And so the fabric takes the responsibility to take in files and streams as they are, to do all of this intelligence inside, and to put out standard formats on the outside. And we run this then decentralized network, as I was talking about. Happy to kind of say a little bit more about this in the Q&A. But the great thing about it is infinitely extensible. And what by that I mean that the protocol itself allows for each of those nodes to work as an equal member of this mesh, both in terms of ingest and egress from the fabric. And the way that content distributes has no partitions by design. That also means that it can be expanded at will. As we talked about, the output media comes from just-in-time composition, and we've taken a lot of effort to make the transformation and transport be tightly integrated without any file I/O, which allows for ultra-low latency video, and hence our presence here with the streaming media community. Because the content access is blockchain controlled, it knocks out so much of the complexity around what we typically think of as media rights, and then allows for availability management and downstream distribution management to be in the content. And then finally, because the content versioning is part of its ledger-based history, if you will, in the fabric is a ledger, that also allows the media's history to be directly provable. So this is probably what you were most interested in. That is, what can you do with this, and what are our customers doing with this? At the very top, of course, is distribution. That is directly from source, achieving consistent, low latency, high quality video, and doing that without a CDN in a classic sense, or a public cloud, so to speak. The fabric generates H.264, H.265, multi-format, ABR dash, and HLS. That includes all options for DRM, standard DRM. The DRM, of course, is applied in line with the fabric's generation. And because of the architecture of this, not because of brute force or how should I say, hardware, the time to first byte is consistent globally. And it is, first of all, ahead of the playout deadlines, but able to be extremely low latency and coincident with the broadcast live edge. And this is using standard ABR output to the players, not requiring any new output protocols. One of the things that's very advantageous in use is that VOD and live are effectively interchangeable in this system. As the live streams come in, they are published just like VOD-based streaming is, and VOD assets are automatically created in the Fabric's process of creating live distributions. Also linear sequences, which are basically compositions of live or on-demand programmable units. Those are created directly within the Fabric software. So it means you can do linear channels that originate directly on the Fabric, that can stitch in different programmable components and be driven by data. One of the other, I think, most surprising points, and this really gets to this sort of just-in-time nature, is the video is playable globally. It's published globally upon ingest. And that includes different configurable output offerings for streaming or file delivery, because the output is really a function of the Fabric's pipeline and the metadata that's configured. One of the most important use cases of this is then really to create network-wide content factories. And our first major customers do just that with just-in-time supply chains, where different language versions, watermark versions, DRM, et cetera, are generated directly from the same source film and TV libraries. And then finally, I want to say a little bit with huge respect to the streaming media audience that we have today, which is what does this really mean for scaling? Because there's been a dream, I would say, at least my entire career, to have more flat networks, or quote unquote peer-to-peer networks, really work. In the past, they haven't. They haven't because frankly, the underlying, if I could call it this, decentralized hashing or distribution protocols have degraded with some or multiple dimensions of scale. They get slower as you add more content or more nodes. The other thing that has been a sort of dream of everyone is to be able to bring distribution composition to the edge. And of course, there are lots of small examples of that, but they're very brute force in the more traditional approaches today. And this approach, because of the functioning of each of those layers and avoiding, some of the pitfalls of prior architectures, and then really building on the idea of if you will, decentralized technologies, allows this to scale with great lightness. And it's also very efficient. And that allows us then, as we've gotten into some bigger things, which I'll talk about in our customer cases, to be able to just grow this, to grow it where the transcoding throughput is very predictable, where each of the nodes can act as cache for the others and not requiring any specialized caching. And then finally, to have none of the burdens of file I/O, which I for better or for worse, know so much about from so many years of dealing with high-speed file transfer. This simplifies the supply chain a lot, and I'm not going to go into all the details about that, but it essentially takes away so much of the burdening there, allows for direct remonetization of the content, and you'll see in our use cases how customers are doing that, and it allows for personalization that's natively part of the content itself. So just wanted to share, so what are some of our customers doing with this? Probably the most important thing is that the content fabric becomes a new intermediary substrate that eliminates the need for so many of these intermediary things, obviously cuts cost hugely, but allows for agility in standing up multiple sites and multiple sites for streaming of all kinds. Those might be public websites. They might also be just VOD streaming sites. They might also be private sites that are being used for exclusive access in some form or another. And with that, then the fabric really takes over what have been the traditional roles of a static and a dynamic CDN. But then it goes further than that, because since the source streams and source assets are coming in directly into the fabric, it also eliminates much of the upstream costs that go along with having to run a publishing and packaging pipeline that sort of leads up. And then it also means that the master storage, for instance, of title and video libraries can go back to cheapest storage rather than having to be locked into expensive active storage, which is a big deal in terms of the huge cost that the public clouds are costing media companies right now due to the active storage volumes that they require and the cost of that. And then finally, I wanted to mention the use of metadata, right? So objects in this approach are linked representations of media, which include the data in the object itself. And that is really foundational to the way today's use cases work. Active content is driven not only by the video and the audio, but also by the metadata that's part of that. And as you build objects and those link together, right, much of what we want to do can actually be described by metadata. For example, if we want to apply a watermark that's personalized to content and then have a different watermark show in a different context, and if we want to be able to bring in anything about the user's session directly into that watermark without having to change any of the upstream content or republish. I also want to talk to you a little bit to live streams during this part of my talk, because it's often that one has to divide VOD and live content into separate workflows. Live is difficult to do at scale, and it has, in this kind of environment, it's actually published in the same way as VOD, and it's consistent in serving out fragmented MP4 2-second segments that are at the broadcast live edge. With that, those two can combine together so that you can create hybrid sites that avoid file copying. Those can also allow for having a representation that is static through static slugs that are then dynamically resolved directly through the fabric. And then finally, in terms of the security is actually a trustless model. And I'll say just a couple of points about this, both for streams and file-based assets. As the content object parts are created, those are not only encrypted in a classic way, they're also encrypted with a new form of cryptography that allows for trustless re-encryption on access. And that two-part encryption then allows for the nodes and also the, if you will, the software of the fabric to not have to be a trusted entity, because re-encryption on access does not expose credentials or does not expose keys to that process, and of course not to any of the participants in the system. So finally, I want to talk a little bit about audience and use cases as I wrap up my 15 minutes. Don't want to go too long. One of our first customers was MGM Studios. They deployed this model first to build a new website. And that website, mgm.com, you can test out. That's all backed by the fabric in this non-traditional new way. And recently they launched the Roar site, which has the entire film library and all TV content directly available from the fabric for screening and licensing, asset servicing, download. And one of the most exciting things that is really first of a kind and something that we're getting ever more involved in is a new format for ticketed live events. They actually ran a global premiere or screening of a global premiere of this concept of Bill and Ted's Face the Music, where all of the new Bill and Ted's release, as well as a couple of the previous in the series films were shown directly on the fabric, and the tickets for that are literally enforced through the access control that the fabric provides. Those tickets are effectively on the blockchain. They had limited use terms that are coded into the authorization policies around the full-length film object and the supporting assets. That was very exciting because each of the viewers received an individually watermarked stream that was generated just in time from the fabric. It was high bit rate, 20 megabits at the top bit rate, served globally, direct from source. And that was offered through the Eluvio tvOS app and also through a browser experience. One of the things that we see happening with COVID is that obviously live events are everywhere, but this turnkey approach where you have ultra high quality, it's very simple and immediate to deploy, and the access through the ticketing is just built in is becoming quite popular. And then also just a couple more notes. So one of our other interesting customers here in the US is Fox, and they use the fabric for several things. Got started in a lightweight way for just stand-up VOD sites for award screening and whatnot. But that has recently grown into some interesting work around next generation linear channels, which I'll talk about in a moment. All of these use cases use our public APIs, which you can check out at GitHub. At eluv-io. Just one more note, some of our customers are startups, so they're involved in new things like mobile streaming. Ficto is one that has all of their mobile content streaming directly from the fabric, and also has branching story narratives working in this model. And then finally, as I was going to mention, one of the latest things that we were involved in this summer is just-in-time linear channels. And I'll just use this to cap off. There is very interesting because the request from the player to stream the channel not only causes the fabric to generate the live VOD manifest, but it also, see if I can do this right here, there we go, allows the fabric to insert media slices, and those media slices are built from playable objects. They are a function of the authorization policy that's part of the object, which can come straight from SCUDY 224, and also the audience context, such as the geography of the user or other profile information about the user. And then finally, this process is literally driven by events, both classic events that are captured from the stream sources, such as SCUDY events, but also data-driven events, such as API-based events that are raised directly in the software, as well as just a scheduled time. And the beauty of a system like this is it makes it very lightweight but frame accurate to have personalized channels. And of course, it has great agility as compared to traditional broadcast air chains. And then finally, it can be self-service.